Hi everyone, my name is Sophia and welcome to Underqualified. Today we're going to be talking about cephalopods. Now, what are cephalopods? Cephalopoda is a class that falls into the phylum of mollusks, and it encompasses octopus, squid. I just forgot. Hi everyone, my name is Sophia and welcome to Underqualified. Today we're going to be talking about cephalopods. Cephalopods are a class of animals that falls into the mollusk phylum that consists of octopi, squids, cuttlefish, and nautiluses. The word cephalopod comes from the Greek words cephalo, which means head, and pod, which means foot. Early in their evolution, cephalopods relied on the sturdy protection of shells, but over time many eventually lost the outer shell and instead relied on new adaptations like heightened intelligence, a talent for hiding, and strong, flexible arms. Essentially, they went, "Mama didn't raise no bitch," and then just threw off their shells into the wind. Into the current. I amaze myself. Okay, anyways. They're just better than us. Probably not physically, because I think they'd get all, squishy if they came onto land. But they're just so much cooler than us. For example, they have this copper-based blood, which is better for adapting to, the various water pressures that they have to live in, and also better at regulating temperature. Now, maybe I shouldn't be applauding them for something that they develop in order to survive, just because they live in the deep ocean, and we don't, so maybe I shouldn't be comparing copper versus iron blood. But part of me just knows that the copper blood is better because it indicates that they had the foresight to stay in the water and avoid things like mosquitoes or melanists. The general anatomy of the cephalopods is essentially that they have a mantle, a mouth, and arms surrounding that mouth. And they can also have a ton of arms. There's obviously a minimum of 8 for our friend the octopus. Then there's a minimum of 8 arms plus 2 tentacles for squids. And then the nautilus comes along and goes, "Y'all are chumps. I got 90 arms." We're gonna start off with my favorite of the bunch, octopi. Now, octopi have a decentralized brain, so they have 60% of their neurons just in their arms, leaving the actual brain for, to contain learned behaviors. Their arms move individually with one another, and they have this one long neuron that runs through the entirety of the arm, kind of like a spinal cord, if the spinal cord was combined with one of those really crappy flexi rulers that you used to get in middle school. The motor capabilities of the octopus's arm have inspired a lot of research, specifically research being done by a neuroengineer at Michigan State University for prosthetics. It's so freaking cool. In fact, it's so cool that it has $2.35 million worth of research behind it. But that isn't even all that the octopus has done for the medical field. The suction cups that line their arms have inspired the development of new adhesives that keep their sticking power in wet environments. More specifically, like a fresh wound. The way that the suction cup works is that it traps water in the actual cup, and then there's little pockets up here that when the octopus presses down the cup, all of the water vacates into these gaps up here, and then when it pushes back up, it creates this air pocket, this really, really tight air pocket. Octopi have contributed more to the engineering field just by existing than I ever will in my entire life, and that's why I know for a fact that they are cooler than you are, and me, and you, and me. Mostly you. Another reason why octopi are cooler than us is because they can edit their freaking RNA. Okay, so how this works, I had to whip out my bio notes to understand this, because it's been over a year since I've actually looked into DNA things. So how it works is that we all have DNA, right? And then this DNA is transcribed into RNA, which then translates into the creation of proteins. So basically, by changing only the RNA and not the DNA, the octopi can get like whatever protein they need at the moment, but then the general octopi DNA remains intact, which could also mean that they're just way older than we think they are, because how scientists date the age of certain species is by like the mutations that are made through the DNA. But if those mutations are slowed down a heck a lot because of just RNA editing, then they could just be like old. Like we could just have some real Methuselahs on our hands. Hi, editing Sophia here. So I just wanted to say that humans also have access to RNA modification. RNA editing, excuse me. It's just that a lot of RNA editing for humans is done in the name of curing diseases, most amazingly in curing cancer. I just thought that it was pretty remarkable to see in octopi, because like that's just something that's like built into them. Like they can just do that to themselves, and like we can't. So I thought that they deserved props for that. And this last thing I'm going to say about octopi, it isn't necessarily something that we don't do, that they do, but I just think that it's really cool. There's this one species of octopi called the gloomy octopus, and they've been found, like, I think it was off the east coast of Australia. There's been different sightings of communities of, like, 15 or so octopi that are called Octlantis. Octlantis. Which I just think is so cool. Like, in several of the articles that I found about Octlantis, the scientists saw, like, the octopi communicating with one another, evicting each other, which I thought was a really funny way to phrase it, but it honestly is what's happening. Like, a dominant male is just kicking out, what's the opposite of dominant? That doesn't sound weird. The non-dominant. The non-dominant male is just kicked out. I'm sorry, I keep moving the camera. I've got like this really janky setup. Some species of squid have these things called light organs, which is essentially just like this bag. I'm really sorry for describing organs as a bag, but it's kind of like this bag of bioluminescent bacteria, which essentially allow the squids to glow in the dark or to camouflage themselves from predators that are lower than them, because the predators look up and they just see light. They just see light. Oh, and also, the biggest giant squid was recorded to be 56 freaking feet. Okay, that's 11 of me, that's 3 giraffes, and that is 1/16 of Vatican City. Now we're going to move on to cuttlefish, and here I'm obviously going to have to be talking about camouflage. I could have talked about camouflage with octopi, but I was already giving them a little bit too much time. So cuttlefish. Cuttlefish have 2 means of camouflaging themselves. Firstly, they have these little structures under their skin that they can, like, they can extend and retract. to give their skin not just the appearance of a different texture, but just a different texture altogether. And they can also change the color of their skin through specialized cells, pigment-holding cells called chromatophores. The chromatophores, to my understanding, operate like little mirrors. So if the cuttlefish wanted to change the color of its skin, it could kind of like tilt the mirror, and then it would be projecting a different color to the viewer. This results in some really stylish cuttlefish. Like, look at this guy. And look at this guy. Like, they're just, and they're so cute too. Also, they got little W-shaped pupils. Because they're winners, and we're all losers. They also can see... So, for the most part, cephalopods are colorblind. But they can see polarized light. The octopi kind of can, but the cuttlefish have the most reactivity, or they're the most sensitive to changes in polarized light. Don't ask me to explain what polarized light is, because I don't know. I don't know what polarized light is, and I mean, I can't be expected to be doing all the work here. Finally, we're going to move on to Nautiluses. I admittedly don't have much to say about the Nautilus, but something that I did think was cool and that separated it from the rest of the cephalopods, obviously aside from them actually having an external shell. Instead of relying on jet propulsion for a majority of their movement, they kind of rely on buoyancy to move. And the issue with relying on buoyancy and being more of like a deep sea creature is that the gases within the Nautilus's shell are more difficult to regulate, especially if the Nautilus wants to move from like different elevations, which I'm assuming it would want to, considering it can't just go in a straight line for the rest of its life. But yeah, pretty much if the Nautilus is in, then the volume in which the gas can like take up is smaller. But then if the Nautilus was to go up, then the gas would automatically want to expand. That's just Boyle's law. I'm saying that like I really remember what Boyle's law is, but it's been a while since I actually took chemistry, so So essentially, in order to counteract like what the gases within the Nautilus's shell naturally want to do, the Nautilus kind of has like a submarine John going on. The different chambers of the Nautilus's shell, if the Nautilus is trying to move around, it can transfer fluids from one chamber to the other, like as a means of like alleviating some of the pressure in the individual shells, so they can move wherever they want. I don't really like the Nautilus. I don't like that it has 90 arms, all the better for punching you, my dear. But I do think that the paper Nautilus looks really cool. I just did a bit of research, and the paper Nautilus is actually just a type of octopus. I'm sorry to all the Nautiluses watching me out there. Love ya, but not as much as an octopus. This video kind of turned too science-y for when I wanted. I know that last week after I wrapped up all of the Disney videos, which you can watch here, I know I said that I wanted to move on to something more science-y, but I didn't intend to get as science-y as I wanted to. I think I was kind of just like grappling for something that I liked about Nautiluses, honestly. So I'm just gonna end this video on like a fun note with a little fashion show for all of our cephalopod friends. Sorry that this video is a bit of a mess. Sorry about the camera quality and the audio quality, because I'm just recording on my phone at the moment. I just wanted to have fun and sit down and just edit something and talk about octopi. But if you want to talk about octopi, because let's be real, we were only here for the octopi. If you want to talk about octopi with me, or if you feel like I left out something important, leave a comment down below. I'm always willing to learn from other people, because after all, I'm underqualified.